this video, we'll work through the solutions to take-home problems number 6. Today was all about word problems, and this type that we're seeing here is one of the easiest types because they're giving us an equation. It's much harder when we have to come up with our own equation. So our task here is to figure out what do the two variables in this equation represent, and then look at the given information to figure out what to plug in for which variable. So we can see here that I is the monthly income in dollars, so the units are important here as well, and T is the number of months the person has been on the job. And so now the question is how many months. So when we see how many months and we know T is the number of months, our big question here is going to be what is T? We're not going to know what T is because they're asking us how many months. That's how we know what we're going to be solving for. So if the two variables are I and T and we're supposed to figure out T, then somewhere they've got to tell us what I is. And so we can see that their monthly income is $2,400. I is the monthly income, and so that means that I is $24. So another way to think about what this question says is what is T when I is $2,400? So we take our equation, I equals 60T plus 1,200, and we're going to plug in 2,400 for that I. And now this just becomes a one variable in your equation that we can solve. We'll subtract 1,200 from both sides. That gives us 1,200 equals 60T. Divide both sides by 60, and that gives us T equals 20. Now, in any word problem where the variables represent quantities that have units, we should use units in our answer. So we solved for T. We look back at the word problem, and we see that T is the number of months, and so that means that 20 is the number of months. And so 20 months is our solution. This is another example of that easiest type of word problem where they give us an equation, and now our tasks are to figure out what the variables represent, plug in for one of the variables, and solve. So again, reading back through the problem, we see that C is the number of cups that this woman, Jess, sells, and then the price is P in dollars per cup. And so we have this equation. Now we read the question. The question says, what price, something, something, something. So that right there tells us that we're trying to figure out the price. So the question that we're asking ourselves is, what is P? And then we keep reading. We say, what price should she charge to sell 200 cups? C is the number of cups she sells. So the question is asking us, what is P when C is 200? So we're going to take our equation, C equals 400 minus 60P, and we're going to take the 200 and plug it in for C. And then that's going to figure out what P is. So if we don't like the P being on the right-hand side of the equation with the negative sign, we can add 60P to both sides and subtract 200 from both sides. Divide both sides by 60, we get P equals 200 divided by 60. And that works out to be 3.33333. Now again, we need to apply units and figure out, and since we've got a non-repeat, since we've got a decimal that doesn't terminate, we've got to figure out how many decimal places we want. So P represents price, so this is dollars and cents, and then the question asks us to round to the nearest cent, and so that means we're going to round to 2 decimal places. So our final answer here is going to be $3.33 per cup. Remember that this was the price in dollars per cup. So that's our solution. All right, now we get into a harder type of word problem where we're not given an equation, but we have to come up with our own equation. This is a type of problem called a mixture problem. And usually with mixture problems, there's a before and an after. So we have a mixture, and then we do something to the mixture, and then we have an after where the mixture has changed somehow. So in this case, we are starting with a mixture where we know we have 3 gallons. So she's adding pure antifreeze to 3 gallons of a mixture. So before, we have 3 total gallons. And we know that that mixture is 40% antifreeze. So the mixture is water and antifreeze. So before, we think how much water do we have and how much antifreeze do we have? Well, if the mixture is 40% antifreeze and there's 3 total gallons, then the amount of antifreeze is 40% of 3, which works out to be 1.2. And if it's 40% antifreeze, then it must be 60% water. So the amount of water that we have before is 0.6 times 3, which is 1.8. So we're just making a little chart here. So we've got the total, and we've got the water, and we've got the antifreeze. Now, after, so what's happening? What are we doing to the mixture? Well, we're adding pure antifreeze. But we don't know how much antifreeze we added. That's the variable. That's what we're trying to figure out. So when we're thinking, how much antifreeze did we add? That's what we're going to call X. So if we're looking in the after column, we started with 1.2 gallons of antifreeze, and we added X gallons. So after, we have 1.2 plus X. We didn't add any water, so the after water is the same as the before water, namely 1.8. Now, we had 3 total gallons, and we added X gallons, so the total also went up by X. All right, this doesn't give us an equation yet, though. The one piece of information we haven't used yet is the fact that the resulting mixture is 55% antifreeze. So this 1.2 plus X, this amount of antifreeze, is 55% of the total. And we know that the total is 3 plus X. So there's the equation that we have to solve. 1.2 plus X equals 0.55 times 3 plus X. And we're just going to solve it the way we normally do. We'll multiply out the right-hand side. 0.55 times 3 works out to be 1.65 plus 0.55 times X. I'm going to subtract 0.55x from both sides. That gives me 0.45x on the left. And I'm going to subtract 1.2 from both sides. That gives me 0.45 on the right. Divide both sides by 0.45, and I get x equals 1. So x represented the amount of antifreeze. We figured out what x is. The question is asking us how much antifreeze we added, so x is the answer to the question, and the units here are going to be gallons. All right, another mixture problem here. This one involves per unit price. So we've got 2 different types of coffee, and we're going to try to mix them together to create a blend. So in this case, the key idea you have to keep in mind is that the total cost is equal to the per unit cost multiplied by the number of units. In this case, we're talking about pounds of coffee, so the units are going to be how many pounds we have. Now, the 2 types of coffee are Kona coffee and Colombian coffee, and so the equation that we're going to set is the Kona cost plus the Colombian cost, and that's going to equal the total cost. Okay, now we need to start filling in some gaps. So the Kona cost is going to be the per unit cost, the cost per pound of the Kona coffee, multiplied by the number of pounds. So what's going to go here is the cost per pound, and what's going to go here is the number of pounds of the Kona coffee. Same thing for Colombian, and then the same thing for the total. Per unit cost times the number of units, so cost per pound times the number of pounds, and then finally same thing for the total, the cost per pound times the number of pounds. And a lot of this information is in the problem if we can find it. So we know that the blend, the new blend, will sell for $4.10 per pound. That's the total, that's the mixture. So that goes here under the total. We also know that Kona coffee sells for $5.85 a pound. And that means that that $5.85 is going to go here under the Kona cost. Similarly, the Colombian coffee sells for $3 per pound. That's going to go here under the Colombian. We also know that we want 100 pounds of the new blend. And that means that the total number of pounds is going to be 100. But that's all the information we got. So we've still got 2 empty spaces, and we're trying to figure out how much of each type of coffee we're going to use. So for example, we don't know what the number of pounds of Kona is, so we could call that X. But we also don't know the number of pounds of Colombian. And we want to try to resist the urge to call that Y, because if we use 2 different letters, then the ability to solve our equation is going to be much less, because we're not going to be able to figure out what those 2 letters equal with only one equation. So here we have to be a little bit clever, and we have to realize, well, if there are X pounds of Kona coffee and 100 pounds total, then the number of pounds of Colombian is going to have to be 100 minus x. And that's how we're going to get our single equation with our single variable. Okay, so let's work this out. So on the left-hand side, we've got 585x. We'll distribute that 3, so we get 300 minus 3x. And then 4.10 times 100 is 410. Subtract 300 from both sides, that gives us 110 on the right. 5.85 minus 3 is 2.85. And now we're going to divide both sides by 2.85. We get 110 divided by 2.85. Putting that in our calculator tells us that this is approximately 38.5964. And now we have to make sure that we answer the question. So the question says, how many pounds of each type of coffee should we use? Round to the nearest tenth. So if we round this number to the nearest tenth, this becomes 38.6. And now remember what x represented. So x represented pounds of Kona coffee. So pounds of Kona. And then 100 minus 38.6, we work that out on our calculator as well. And that gives us 61.4 pounds of Colombian coffee. And that answers the question, and we're done. So the really clever step here was realizing that if there were X pounds of Kona coffee, then there were 100 minus X pounds of Colombian coffee. And that's the kind of thinking you have to do sometimes with these problems. So pay attention closely to that step and how it helped us. All right, one last one of these word problems, this one again involving per unit cost. So again, the principle is going to be that the total cost is equal to the per unit cost multiplied by the number of units. In this case, once again, we're making a mixture with pounds, so the units are going to be pounds. So our mixture is a mixture of cashews and almonds. So the cost of cashews plus the cost of almonds is going to equal the total cost. And again, the cost of the cashews is going to be the per unit cost of cashews times the number of pounds of cashews. Same thing for almonds, same thing for the total cost. So again, this is going to be the per unit cost. This is going to be the number of pounds. This is going to be the cost per pound. This is going to be the number of pounds. So all of these products are the same, pounds. And this is going to be the cost per pound. And this is going to be the number of pounds. And again, a lot of this information is given to us. So the cashews sell for $9 per pound. So that's the cost, the per unit cost for the cashews. The almonds sell for $3.50 a pound. Now we know that the mixture we want it to sell for $7.50 a pound, so that's going to be the cost for the total for the mixture. And then we're also told that we're going to want to use 60 pounds of almonds. So we know that the number of pounds of almonds is going to be 60. And now the question is, how many pounds of cashews are needed? So if we call that X, then that X is going to go right there with the cashew cost. The number of pounds of cashews is unknown. We call that X. That's where the X goes. All right, but now what do we put over here with the total number of pounds in the mixture? What goes there? Well, again, we have to think kind of cleverly, similarly to what we did in the previous problem. But this time we know that we have 60 pounds of almonds plus the mysterious X pounds of cashews. So if we add those together, that's going to give us X plus 60. That's the number of pounds in the mixture. We have X pounds of cashews plus 60 pounds of almonds gives us X plus 60 pounds in the entire mixture. And there's our equation. So solve. On the left-hand side, 9 times X, 9X. 3.5 times 60 is 210. On the right, 7.50, so that gives me 7.5X. 7.5 times 60, that's 450. And now let's see, let's subtract 7.5x from both sides, that gives us 1.5x. Subtract 210 from both sides, that gives us 240 on the right. Divide both sides by 1.5, that's 160. So again, x represented the number of pounds of cashews, so that's pounds. And x was the answer that we were looking for, and so that ends the problem. So again, have to think a little bit cleverly to realize that the number of pounds in the mixture is x plus 60, but it's a similar type of reasoning to what we did in the previous problem.